So hello everyone, in this audio class we will discuss the 20 most important questions which can be asked in the interview level of KVS and NVS geography postgraduate level teaching recruitment process. So let's get started with question number 1 from the chapter Origin and Evolution of the Earth, chapter 2 of the book Fundamentals of Physical Geography. So let's get started with question number 1. What is the most widely accepted early theory regarding the origin of the earth? That is the nebular hypothesis proposed by Immanuel Kant and revised by Laplace in 1796. It suggests that the planets were formed out of a cloud of material that is called nebula associated with a youthful sun which was slowly rotating, for example like a spinning figure scattered drawing their arms in. The nebula collapsed and accelerated, forming a central sun and planetary rings. Next question, how does the binary theory differ from the nebular hypothesis? So while the nebular hypothesis involves a single sun, the binary theories proposed by Chamberlain and Moulton suggests that a wandering star approached the sun, causing a cigar-shaped extension or filament of material to separate, which later condensed into planets. Next question, describe the Big Bang theory in the context of modern cosmology. So Big Bang theory is known as the expanding universe hypothesis. Edwin Hubble provided evidence in 1920 that the universe is expanding. It posits that all matter existed in one singular atom with infinite temperature and density, which exploded roughly 13.8 billion years ago. Next question, question number 4. If the universe is expanding, does that mean that galaxies themselves are growing? So no. While the distance between the galaxies is increasing, the galaxies themselves are not expanding. For example, if you draw dots on a balloon and blow it up, the distance between the dots increases, but the dots or galaxies stay the same size. Next question, question number 5. How do stars originate according to the earlier hypothesis? So stars form within galaxies from vast clouds of hydrogen gas called nebula. As localized clumps of gas developed with these nebula, they grow into even denser gaseous bodies, eventually starting nuclear fusion. Next question, question number 6. What are planetesimals and what is their role in planet formation? So in the initial stage, the gas cloud starts getting condensed into small rounded objects called planetesimal. These collide and stick together by the force of gravitation, forming larger bodies that form the planets. Next question, distinguish between terrestrial and Jovian planets. So terrestrial planets, Mercury to Mars, are small, rocky and have high densities. On the other hand, Jovian planets from Jupiter to Neptune are giant, gaseous and have low densities. Next question number 8. Why are the terrestrial planets rocky while the Jovian planets are gaseous? So terrestrial planets were formed in close vicinity of the parent star, where it was too warm for gases to condense. Also, the solar wind was most intense near the sun and blew off lots of gas and dust from these planets. For example, like a strong fan blowing away light feathers near the motor while heavier stones remain unmoved. Question number 9. Explain the giant impact or big splat theory regarding the moon. So it is believed that a body the size of 1 to 3 times that of Mars collided into the Earth shortly after it was formed. It blasted a large part of the Earth into space, which then started orbiting the Earth and formed the moon about 4.44 billion years ago. So question number 10. What is primordial differentiation and how did it affect Earth's interior? So differentiation is the process by which Earth's materials were separated based on their densities. Heavier materials like iron sank to the center to form the core, while the lighter materials moved towards the surface to form the crust. Next, question number 11. How did the Earth's atmosphere evolve from its primordial state? So the early atmosphere that was hydrogen and helium was stripped away by the solar winds. The second stage involved degassing, where gases like water vapor, nitrogen and carbon dioxide were released from the interior during volcanic eruptions. Next, question number 12. What is degassing in the context of atmospheric evolution? So degassing is the process by which gases were released from the Earth's interior into the outer layer. This contributed to the formation of the early atmosphere dominated by water vapor and carbon dioxide. Question number 13. How did the oceans come into existence? So as the Earth cooled, the water vapor in the atmosphere condensed, leading to continuous rain. These rains filled the giant depressions on the Earth's surface, forming the oceans within 500 million years of the Earth's formation. So question number 14. When did life begin on the Earth and in what form? So life began about 3800 million years ago. Initially it was confined to the oceans as simple single-celled organisms called cyanobacteria that were capable of photosynthesis. So question number 15. How did photosynthesis change the Earth's atmosphere? So photosynthesis contributed oxygen to the oceans. Once the oceans were saturated with oxygen, it began to leak into the atmosphere, eventually reaching its current levels about 2000 million years ago. Question number 16. What is solar wind and why is it geologically significant? So solar wind is a stream of charged particles released from the upper atmosphere of the sun. It was responsible for stripping the primordial atmospheres of the inner planets. Question number 17. Describe the light years as measure of distance. So a light year is the distance light travels in 1 year at a speed of 3 lakh km per second. It is a measure of distance, not time. Question number 18. Explain the Goldilocks zone or habitable zone in simple terms. So it is the region around a star where the temperature is just right, not too hot nor too cold for liquid water to exist on the planet's surface. Earth occupies this zone. Question number 19. What was the Precambrian era? So it refers to the earliest part of the Earth's history, covering about 88% of the total geological timescale before the explosion of the complex life forms. So question number 20, and this is the last question for today. Why is the study of origin of the Earth essential for a geography teacher? So because the Earth's origin dictates its physical structure, its atmosphere and the distribution of resources. to understand where. In geography, we must understand how or the origin of it. So this is for today. Thanks for listening. Keep listening for further audio classes.